Gee, I'm a tree. Okay, so today we're going to talk about another transformation called a reflection. And you guys should know what the term reflection means from your lovely little thing you do when you look in the mirror every morning and go, oh, I need to make myself look all pretty for everybody. Anyway, so let's just define it real quick. Basically, reflection is a mirror image of a point over a certain line. Now, this gets a little confusing because sometimes there's different directions. And of course, we're still in the coordinate plane. That's what we're working with. So, what we can first talk about, we're going to talk about some common reflections. You need to memorize all of these little tricks. Otherwise, you have to be able to figure them out. So, some common reflections, the first one is little r, this time means reflection. And this is saying reflection over the x-axis. And when we take the point xy, it'll become x negative y. Now, the reason for that is, take a look. If I have this Domo says hi, yo, yo, yo. And let's say that he's hanging out over here. Okay? Now, basically, reflection over the x-axis means that we're talking about this line right here. Another Domo, I'm nerdy Domo, he needs to be the same exact distance away. So if you notice, he is 1, 2, 3, 4 away, and he's going to be 1, 2, 3, 4 away. So if they want to be the same distance away, their x values are going to be the same. They're both on 3. This one's at 4, and this one's going to be at negative 4. So as you can see, they're the same. They're a reflection of each other. Obviously, they don't look the same because they're a little different domos. And oops, and I moved that down. Okay. Anyway, so the reflection on the y-axis basically is the opposite of what the x-axis is. We have negative xy will become negative xy. Now the key thing with this is when you're reflecting over the x-axis, it'll become you're not changing the x value, you're negating the y value. Same thing here, you're reflecting over the y-axis, y stays the same, but you negate the x. A little trick for you to remember it. Now, one time they also mentioned this reflection, the reflection over the line y equals x. If remember, the line y equals x is actually the line that goes diagonally across. Okay? It's a little bit more confusing, but basically what you're going to do, take xy, and you're going to flip them around. So it's going to become yx. Okay? Now, there are other reflections. We're going to talk about those in an example, but let's first look at this one, an example. Find the result of the reflection of the y-axis on negative 3, negative 4. Now, if you remember our rule, for the y-axis, we keep the y the same, we negate the x. So I'm going to keep the y the same, so it's going to be negative 4, negate the x, so negative 3, negate that, it'll become positive 3. Easy. Now find the result of the reflection over the line y equals x on the point negative 2, 3. Now if we use negative 2, 3, and we want to use the reflection y equals x, you need to remember you're going to switch the x and the y value. So in this case, the 3 will come over here and be 3, and the negative 2 will become negative the y. So therefore, your reflection point will be 3, negative 2. This is where it's going to move. Okay. Now we're going to take a look at this example. We're going to find the result of the reflection over x equals negative 1 on the point 1, 2. First, this is a little bit more difficult to do just by looking at the numbers. So what we have to do is we plot the point 1, 2. Okay. Now, we're going to reflect over the line x equals negative 1. First thing we need to do is find that line. Now, if you remember, y equals goes over the y-axis, x equals goes over the x-axis. So, the line of reflection is over here. Now, remember, Dorky Domo is standing here. He is 2 steps away from the line, line over here. So if his friend wants to be on the exact opposite side, you're going to count 1, 2, and then move over 2 over here. Now, this point is going to be negative 3, 2. And that'll be your reflection point. That'll be the result. Okay. So here's some examples for you to try on your own. Otherwise, we can just talk about this later. Bye.